Hi viewers, welcome to LMS Solution. Today we are going to see about PSO ANFIS MPPT for grid connected TV system. This is a simulation model we created for PSO ANFIS MPPT controlled grid connected TV system. This model consists of PV array and then PV inverter and then coupling inductor and then it have grid and then it have local load. And this inverter going to be controlled by means of PSO tuned ANFIS MPPT and the voltage and current control logic. The PV panel rating is, here you can see that the single panel rating is 213.5 watts, having 18 panel string and single string having 25 panel in series. We can generate maximum around 96 kilowatts. Here you can see that for in order to control this inverter, it is known as a single stage converter. That means single stage conversion of a grid connected PV system. Now to control this inverter, we go with a voltage control and current control. We not to go with the voltage control. Here we are going to use ANFIS MPPT. That means ANFIS MPPT is going to be trained by means of it going to be receive two input, irradiation temperature. So the output will be reference voltage. So this reference voltage going to be combined with this reference voltage is a reference voltage and is going to be compared with the DC link voltage. This reference voltage should be made it across this DC link, then only we can extract the maximum power from the PV panel. Here you can see that VDC reference and that VDC when we compared here and then process via PA controller, it will be generate the DC link current. And another thing, we need to have load current. Here we are using load. That load current should be we have to measure. That load current going to be measured by means of ISO FLL frequency lock loop. For that, here we are measuring the load current. Here we are measuring load current. Based upon load current, we have to calculate ILVA, ILDB, and then here we are calculating ILDC by using that ISO FLL. After by using that ILDA, ILDB, and ILDC, next you have to calculate IL. This is a calculation for IL by using ISO FLL. This is ISO FLL for a single phase. For each phase, you have to calculate that direct axis component. After calculating the direct common axis and that mean detail, current detail, next you have to calculate the IL. For in order to calculate IL, we need to calculate UPA, UPV, and VPC. Here you can calculate the details based upon the line to line voltage. You have to calculate phase voltage. After calculating phase voltage, you have to calculate the terminal voltage of the grid, and then based upon the phase voltage and terminal voltage, you have to calculate that unit vector voltage. That means UPA, UPB, and then UPC. This will be going to be used for calculating that IL value. So this IL will going to be used here. Another current, nothing but the load current. So next you have to calculate the another thing. That means source current. Here source will be the PV current going to be calculated by means of here you can see that we are measuring the power of PV. Just you have to multiply voltage and current. Just you have to multiply that voltage and current. Finally, you will get PV power based upon the TPM and the terminal voltage, grid voltage. Here we are calculating the source voltage. Here we are taking the source voltage and going to be separated with the load voltage and then DC link current. The remaining current will be going for a grid. That means we are separating this load current and then DC link current with the source current. Then we have excess current, excess power. That power going to be sent to grid. This is the logic in this control. Here you will get the reference current for supplying current to the grid. So this going to be multiplied to the unit vector template from that ISO FLL concept and then some voltage concept. That means you have to take that unit vector template and going to be multiplied with the reference current, and then reference going to be current going to be combined with this inverter current, this one. And then finally you will get the error current. The error current when we process via this hysteresis controller. This hysteresis controller will be generate the pulse. So that pulse going to be used. That means this pulse going to be you have to take complement because it is having 6 IGBT. So 3 will be used for control this one and 3 will be used for control this. See, based upon the current reference from this control logic, the inverter will be controlled. And then here the PSO is to for train the ANFIS. So here already we have that data. This is a coding for training of ANFIS. Further you have to provide the data. Data will be taken from the this PV data and then you can be trained for at 10 iteration. Once you executes a program, so these are the program used to for that to train that ANFIS. Once you execute this program, the PSO will start executing, and then you will get final fuzzy inference system after completion of iteration. These are the figure detail about that training data, and then error data and mean square error, and then the mean that relation between target and output both are having superimposed each other. After executing this program, you will get the fuzzy inference system here. This is a fish file generated from that training of ANFIS. This fish file can be used for providing that feed the details here. Here we are using that concept PSO to ANFIS MPPT, and then for extracting the maximum power from the P panel. And then here you can see that here we are measuring the irradiation temperature, and then this is PV voltage, this PV current, and then this is PV power. And then this is used for measuring the grid voltage and grid current, grid voltage and grid current. And this one used to for measuring the power sent to the grid, power sent to the grid. And this is inverter voltage and current, and this is power sent from the PV inverter. One, you can examine this result for 1000 watts per meter square from 0 to 2 seconds. You can see that we are getting maximum power around, 95.8 kilowatt. So we are getting the maximum power from the PV panel. And also you can see here during that time the voltage will be maintained around 725 volt. And after 2 seconds, the radiation changed from 1000 to 500. Because of that, the voltage of the PV is maintained at around 725. And then here you can see that PV power is maintained around 48.5 kilowatts, because the irradiation is comes down to 500. So it generated PV will generate only 50% of the total power. So that's why we are getting around 48.5 kilowatts. So this is a variation of PV current according with the change in irradiation condition. And also here you can see that the current inverter voltage is maintained at 230 volt phase voltage. And then you can see that this is the grid, the inverter current for 1000 watts per meter square. The current value is around 200 amps peak. For 500 watts per meter square, the current peak value is around 100 amps peak current. Right? Again, that irradiation changes from 500 to 1000, then current value comes to 200 amps peak. And then here you can see that this is a grid current. Initially you can see that we are getting around 95 amps peak, because here we are using load is 50 kilowatts. Whatever power generating from the PV, that will be given to 50 kilowatt. That means 50 kilowatt watt. The remaining power will be going to send to grid. That's why you are seeing that the grid current. Here you can see that the inverter current is 200 amps. Here 200 amps, but grid current is around 96 amps peak. That means it is equivalent to the around 46 kilowatts. The grid receiving the remaining power from the PV. Whatever power is sent to the load, the remaining power is 46 kilowatts, that going to be sent to grid. So next we can see that when irradiation changed to 500 watts per meter square, the inverter current is changed to around 100 amps peak. That's why that grid current goes to around near to 0. Why means this power, that means PV inverter power when we used to for supply the local load, and then there is no excess power in the PV. That's why it goes to 0. That can be seen from the power graph. See here you can see that for 1000 watts per meter square, the power around 96 kilowatts. So 50 kilowatt is sent to the load, remaining power will be sent to grid. Now you can see that from 2 to 4 seconds, and PV inverter power is around 50 kilowatts. That will be used for supplying the local load. So there is no power, excess power in the PV side. So that's why that grid current comes to 0. Again, that PV power increased to 96 kilowatt. That's why grid power increased to around 46 kilowatts, because the 50 kilowatt going to be supplied to the local load, and then excess power going to be sent to the grid. Here you can see that as per the result of this maximum power of PV is effectively extracted by means of PSO into ANFIS MPPT, and also water power is generated from the PV that will be sent to the grid as well as supplied to the load. So this is the working of this model. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.